So I'd like to introduce Robert von Katz, if he's there. I can see he's available in the system. So Robert van Katz is the co-founder and architect partner of bkvv Architects. He's also a co-founder and chairman of de Suda. It's a Dutch alliance for sustainable urban development in Africa. His recent work includes a sustainable office complex for Other Side at Work, with the largest bamboo facade in the Netherlands, and the award-winning National Teachers Colleges project in Uganda. So hello, Robert. Good to see you. Can you hear us?
Hello, good to see you, Stuart.
Fantastic. You're there in the line. Lovely. Thank you for joining us.
Well.
It's great to see you again. And I was sort of half expecting you to be running around saying, kill the air conditioning. That is your typical war cry. So I think you're an architect. You have these projects that you've been working on in around the world, but especially I think in warm regions like in Uganda. And as I said, your battle cry has been to kill the air conditioning. But my question to you is it really ethical to enforce an approach like that in developing countries where it's air conditioning that makes it possible for some people to be able to work and contribute to advancing their economies?
Yes, thank you. That's a very good question on those kind of ethics. Who am I as a Buzungu, a white man, being actually also now being in Uganda? But there's a practical side. We are facing projects here, whether it's large school or an office. Simply, there's many times a location that has no power, no energy. So if you have energy, the prices are sky high. So there's a practical side to it. So it is from request of our clients to design much more climate friendly. Yes, that means that we have to invent local solutions that at the end, if we do our physics right, yes, we do kill this airco.
So isn't it enough, though, if we have things like photovoltaic, we have solar energy that can generate electricity, isn't it enough that we use those advanced technologies to generate the power that we need to maybe implement cooling like air conditioning? Isn't that the solution?
It's definitely part of the solutions, all those high-end technologies, which we definitely use. Because at the end, you need a certain amount of energy. But if we put a glass tower in the center of the capital, Kampala, it is basically you're building a greenhouse as an office. So that needs so much cooling and so much energy, you won't reach that with a PV solar system.
Now, one of the things we were looking at when we last met each other was the eco-housing project in Methoni in Greece, and we were exploring how to make buildings there that followed this concept of yours, which is basically architecting a building that doesn't need air conditioning. Could you explain a bit about the work that you've been doing in Uganda and how the sort of the architectural decisions that you make in order to make these types of buildings possible, and what the impact is? Is it as good as an air-conditioned building when it's complete?
I dare to say it is even better. But at the end, it is somewhere in the past, after the invention of the air conditioning unit, somehow doing your physics right in architecture has lost. So basically, it's bringing back, sometimes you could call it traditional knowledge, into very contemporary architecture. That's for me also where the passion is, to go to the extreme, basically, to do our physics right. And if we achieve a 10 degrees temperature difference between outside and inside, we have done a good job.
So what are the sort of the challenges of a typical building? Why do buildings inside get hot? What is it about their design that causes them to warm up, and what do you do in order to make sure that that heating influence doesn't happen in the first place?
Again, it's all about physics. I definitely come to electronics also, and the role in that, but it's basically making sure the space you are in as a human being is not heating up too much. So meaning no direct sunlight. So look at our facades of our buildings in Uganda. You have seen them actually. They might look funny to an outsider, but it's all about you want daylight, but you don't want your direct heat of the sun in. And then the second step is, of course, there will always be some heat building up, like your cooking, your computer, you're just being in there. Human beings are small heaters, so to say. It has to release the air. So we use heat chimneys. Very simple elements, but it's all about reducing the heat inside, the demand for cooling inside, and then high-end technology comes in, like solar, like electronic engineers inventing solutions to steer the airflow in a building, etc.
Now, that's a very good point that you touch on there, because we're here at Electronica 2022, and obviously we have the electronic community and the semiconductor community here. What sort of solutions or sensors, actuators, and other technologies, maybe monitoring capabilities, do you think you really require in order to maybe improve the quality of the buildings that you design, and to maybe get more insights in order to make them better for the next generation of eco houses?
Yes, this is actually what we are trying to work on. It is basically using high-end technology to develop a very local solution. So when it comes to our buildings, it's we are limited in the preciseness of our solutions. So yes, it is physics. Yes, hot air will rise up. But what if an electronic engineer can assist us in those ventilation openings we have to use to, especially in climates, it's basically easy in Africa. But for example, in Matoni in Greece, we want to be more precise because we do have a colder season and a hot season. So when it's a colder season, we want to close off automatically some ventilation openings. So, but how big, how small, what is the kind of technology there? I would love to work with your engineers on this one.
Super. Well, there's plenty here in the room, and many more online. So I look forward to lots of emails providing support. One last question to you before we have to leave. Bamboo is being touted as an amazing building material. To me, it seems like, it obviously grows very quickly in an abundance, but it's not very uniform as a building material in comparison to something like steel. Is it really a serious material for building houses, and are you using it?
Yes, definitely. On the material side, bamboo is, I believe, the future of construction. For what's interesting, yesterday at COP27 in Egypt, a delegation of Uganda from the National Forest Authority and the Empire Bamboo Organization were actually presenting the future of bamboo in Uganda. We are part of that. That means that we're developing products from bamboo that it will take some time, but will start competing with steel and concrete. Definitely.
Well, thank you ever so much for your time and joining us today. I know you're very busy planning further eco-developments and buildings and houses that don't require air conditioning. So we look forward to meeting up again and seeing what buildings are developed next.
Thank you so much. Have a good conference.
Thank you. A round of applause there for Robert van Katz, co-partner of bkvv Architects. Thank you very much.